Hello, welcome to your next lesson. Our first few lessons were all about arithmetic sequences in series. I do believe in my last video, I think I called a series sequence at one point, so sorry about that. But just to clarify, a sequence is when it lists the pattern, and a series is when you're adding the terms together. So I may have said it wrong at one point, but I had it correct in the notes. Okay, normally we would have had another class where we did word problems about arithmetic series, but lucky you, I've omitted the word problems for this course for this year, so we're just kind of going through the basics. We get the key concepts in place so you're ready for next year in calculus. So we are now done arithmetic sequences and series. So we have one last topic to do in the course. We're almost done. Hang in there, everyone. Today we're going to look at geometric sequences. So we're back to sequences. We're not adding the terms, we're just listing them. But instead of being an arithmetic sequence, it's a geometric sequence. So if you've been doing your work this last few lessons, this isn't that bad. There's some new terms, but the basic ideas are the same as before. So a geometric sequence, GP, geometric progression, is a sequence where each term after the first is obtained by multiplying. So remember, an arithmetic sequence, you are adding a constant term. Geometric, you're now multiplying by a constant term. When we added, we use the letter D for common difference, but because we're multiplying, we're going to use the letter R for ratio. But otherwise, it's the same idea. We're going to use our formula sheet for the formulas. We just insert and rearrange and solve. So it's not that bad. Now that we've spent about a week on arithmetic sequences and series, it's not that hard to go on to geometric sequences. You're just multiplying instead of adding by a constant term. So let's look at some examples. So the first example, 3, 6, 12, 24, dot, dot, dot. The 3 dots mean that the patterns continue. That's a GP, a geometric progression or geometric sequence. We're multiplying by 2. Every time you multiply it by 2, so it is a geometric progression, and your R value is 2. Now that's easy to tell. I think you can tell what we're multiplying, but if you have a hard time telling what you're multiplying from, you just divide back. That's why it's called a common ratio. If you can't figure out 3 times what gives you 6, do the ratio. 6 divided by 3 gives you 2. The second term divided by the first gives you the ratio. And then the third divided by the second. So you can do 12 divided by 6, right? So if you have a hard time looking forward, you could just divide back. That's why it's called a ratio. Okay, now let's look at our next example. They kind of went close together here. 2 times negative 2 times 2 times negative 2. Is that a geometric sequence? Sure is. It looks like it's not at first, but the R value is, oh, I heard you, -1. So it's kind of a weird one. It looks like you're just flipping back and forth, but it really is, it's an R value of -1. Okay, so I think that's enough examples. Like I said, if you understand arithmetic sequences, same idea. Geometric, we're just multiplying instead of adding. So back to the salmon-colored formula sheet, which I've left at the back of the room, but you have it by now. Pretend I'm holding up the salmon-colored formula sheet. So we've already done the general term for arithmetic and the 2 sum formulas. So the next on your sheet, you should see this formula. Tn equals T1 times R to the power of n minus 1. So you can tell we use this for geometric because of the letter R. If it was arithmetic, you use the formulas where it's D for common difference. And again, Tn is whatever term we're looking for. T1 is the first. R is the value that you're multiplying by, and then n is the term we're dealing with. So like I said, after about a week of doing arithmetics, it's not that hard to go to use this formula. And again, you have the formula sheet with you. We'll try and do it without a calculator, but some of these numbers get really, really big and really, really small. So like I said, and again, we know we can expand it without a formula, but the goal of this course and the curriculum guide, they do want us to connect the formula to the pattern, so do it algebraically. Now, we're having a hands-in on arithmetics, but not in geometrics, just because we're into the final week of the class term. So I am assuming you're still going to be completing these questions to get practice. This topic does not come up in grade 12 pre-cal. If you go on further to calculus, they do expect you coming in with these foundations of arithmetic, geometric sequences and series. Okay, so let's do a couple examples. The first one, write the 8th term of the geometric sequence 1/2, 1, 2. They didn't say the word geometric, but I can tell it's geometric because I'm multiplying by a constant number. What's the number I'm multiplying by? 2. So I keep multiplying by 2 to get the pattern. So I know that the R value is 2. Well, I didn't, but I just figured that out. My T1 value, the first term, is 1/2. And the N, well, the N is 8. That was given in the question. We want the 8th term. Again, I know we can expand the pattern and see it, but the goal is to do it algebraically using the formulas off of your salmon-colored formula sheet. Okay, and then we've got our new formula that we are using today, the general term for geometric sequence. So we are looking for the 8th term. So N is 8. my T1 is 1/2, my R value is 2, and N is 8, so 8 minus 1 is 7. So again, if you are using a calculator, try and do it without as much as you can. That will just prepare you better for next year and for calculus. But again, if you're putting it to your calculator, every calculator is different, right? You'd have to do your exponents first, then the number. Even with a calculator, you may not get the right answer if you don't know how to type that into your calculator. Okay, so if everything goes well, the 8th term should be 64. Okay, so like I said, similar to arithmetics, just we're multiplying instead of adding. Okay, then our next and final example, determine the first 3 terms of the GP, geometric sequence or progression. It's kind of like that last example we did when we looked at arithmetic sequences. All they give us is that the 9th term is 80 and the 14th term is 2,560. They don't give us the R value, they don't give us T1, and that's what we're used to getting. So it's the same as that last example we did a couple lessons ago. I'm splitting it into 2. I'll do one formula for the 9th term and another formula for the 14th. So for T9, I know that the 9th term is 80. I don't know what T1 is. I don't know what R is, but I know that N is 9, so 9 minus 1 is 8. Okay, and then on this side, the 14th term is 2,560. I do not know what T1 is. I do not know R, but I know N is 14, so 14 minus 1 is 13. Okay, very similar to that last question. Didn't really get us anywhere. We still don't know our R value. We still don't know T1. What do we do next? So when we did with arithmetics, remember we had our 2x2 system and we solved by elimination to get our D value. Well, now this one's actually a little bit easier. We can divide them. It doesn't matter which one you put on top, but I put the bigger numbers on top. So 2,560 divided by 80. I'm just going to keep it as that fraction for now. We don't have to reduce yet. The T1s cancel out. T1 divided by T1 is just T1. And then remember our rules from grade 10, pre-cal or exponent rules. When you divide R13 divided by R to the 8th, 13 minus 8 is 5. Okay, now 2,560 divided by 80 gives us 32. So R to the power 5 is 32, so you take the 5th root of each side. Oh, remember our radicals unit, it's all connecting now. So our R value, that's hard to say, our R value is 2. Okay, so we have our R value, but the question didn't ask for the R value, the question asked for the first 3 terms. So we've got some information, but we still have a little bit of work to do. Again, we have to go back and use one of these 2 initial formulas. Either one works. I tend to look for the one with the smaller numbers because I think it's easier, but it's all personal preference. So I chose to use this one. T9 equals T1 R to the power of 8. I just thought smaller numbers are easier. The question told us the 9th term was 80. I still don't know what T1 is. On the previous screen, we just figured out R was 2. Okay, so then I just fill it in. I did some work ahead of time. So 2 to the power of 8 is 256. Now to solve for T1, we have a fraction. And because I've been working on my mental math skills and all this extra time at home, I know that that reduces to, oh, I'm missing number 5 over 60. Okay, so it's long and tedious, but nothing too hard right now. Okay, does anyone remember what the question asked? I don't think so. It did ask us for the first 3 terms. So we now know that our first term is 5 over 16, and we know that the R value is 2. And because we got a few mental maths in before the break, we know how to multiply fractions. 5 over 16 times 2 is 10 over 16. Remember, you just multiply. That's why we did our mental math at the beginning, so you'd be able to do all the math in all the future units. Then you multiply this by 2, so 10 over 16 times 2. Again, you just multiply the numerator, and that's your terms. So we can leave it like that, but in case you don't remember, the question asked, what are the first 3 terms? The first term was 5 over 16. The second one is 10 over 16, and the third is 20 over 16. I know that I can reduce those. We don't have to. When you go into grade 12 pre-cal, you do not need to reduce your fractions. I think it's easier to leave it just so you can see where those numbers came from. Okay, so you do have your formula sheet. Try and do these without a calculator if you can, but like I said, sometimes the numbers get really big or really small. But you're basically going to the formula using the geometric sequence formula and just solving for the same things we did for arithmetic. Okay, good luck.